Question 1. If y is equal to x squared plus px plus q, and if the least possible value of y is 0, then q is equal to what? So when we talk about the least possible value of y, we are basically looking at the vertex, because if this is my parabola, then I see that here the least possible value of y is 0, right? So if my vertex is h comma k, then k is going to be 0. Now the vertex form of the parabola is a times x minus h whole squared plus k, where h comma k is the vertex. So let's convert this to the vertex form. So to convert the vertex form, I will have to complete the squares, which means that I'll need to write x squared plus px plus q as x squared plus 2x times p by 2. And then I add the square of p by 2, which is p squared by 4. I subtract the square of p by 2, and plus q was already there. So I do that because then these three expressions will become x plus p by 2 the whole squared, and minus p squared by 4 plus q is already there. And this is similar to the expression that we wanted. So if you compare that, then h is negative p by 2 and k is minus p squared by 4 plus q, right? So my vertex is negative p by 2 and negative p squared by 4 plus q. But since the least possible value of y is 0, k has to be 0. So negative p squared by 4 plus q has to be 0. So q will be p squared by 4. So q is equal to p squared by 4, option B. Question 2. Two widths of width 1 overlap at an angle of alpha as shown. The area of overlap shown shaded is what? So these are two strips and the width is 1, right? That's given to us. So if you notice, this will be a parallelogram and the area will be base times height, right? So if I find the base, then the height is 1. So I can simply calculate the area from there. Now, how can I find the base? Let's say I need to find the base. So let me drop a perpendicular like this. So this distance is 1. Now, if this is alpha, then this angle inside is also alpha. And so this angle is also alpha because these will be alternate interior angles, right? So the base B, if I use sine alpha will be opposite over hypotenuse, which is 1 over base B. So base B is 1 over sine alpha, right? So the area of the strip, the shaded portion would be B, which is 1 over sine alpha into the height, which is 1. So that's 1 over sine alpha, option B. If xy is a solution to the system, xy is equal to 6 and x square y plus xy square plus x plus y is 63. Find x square plus y square. Okay, so we are given that xy is 6 and x square y plus xy square plus x plus y is 63. Now, from these two terms, if we take xy common, we are left with x plus y, and x plus y is already there. And then from these two terms, if I take x plus y common, I'm left with xy plus 1. Now I know that xy is 6, so I can write x plus y into 6 plus 1, which is 7, is 63. So x plus y is 9. So now I have x plus y and I also have xy. Now we know that x plus y whole square is x square plus y square plus 2xy. So because we want to find x square plus y square, we can write that as x plus y whole square minus 2xy. Now x plus y whole square will be 81 and 2xy will be 12, and 81 minus 12 would be 69. So x square plus y square is option D. Question 4. One student in a class of boys and girls is chosen to represent the class. Each student is equally likely to be chosen, and the probability that a boy is chosen is 2/3 the probability that a girl is chosen. The ratio of the number of boys to the number of boys and girls is what? So let the number of boys be B, and let the number of girls be G. So the probability of choosing a boy will be boy divided by total students. So that's boy plus girl. And the probability of choosing a girl will be number of girls divided by total number of students. And probability of choosing a boy is 2/3 the probability of choosing a girl. So B by B plus G is 2/3 of G by B plus G. So B plus G cancels out. So the ratio of boys to girls is 2:3. But the question is asking me the ratio of boys to the total number of students. So that will be boys to boys plus girls. So that's 2 by 2 plus 3. So that's 2 by 5. So option B. The diagram above shows several numbers in the complex plane. The circle is the unit circle centered at the origin. One of these numbers is the reciprocal of f. Which one? Okay, so this is the unit circle. So on the real axis, this would be 1, and this would be I, this would be -1, and this would be -I. So if you look at f, right, then I can say that f is about, just for the sake of simplicity, I can say that it is 1.5 plus I, right? Something like that. Because it's here, so on the real axis, it will be about 1.5, and on the imaginary axis, it's a little less than I. So I'm just taking it as I because I need to find its reciprocal. So 1 by f will be 1 by 1.5 plus I, which is 1.5 minus I divided by 1.5 plus I into 1.5 minus I, right? So when we have to divide a complex number, we always take the complement of the denominator. So I get 1.5 minus I divided by 2.25 plus 1. So that's 1.5 minus I divided by 3.25. So if I plug that in the calculator, I will have 1.5 divided by 3.25. So that's 0.46. And I would have 1 divided by 3.25. So that's 0.3. So I have 0.46 minus 0.3i. Now 0.46 will be about halfway here somewhere, right, on the positive x-axis. And negative 0.3 will be here somewhere here, right? Because this is negative 0.5. So the expression for the reciprocal of f is closest to point C. So that's the answer.